Hi, 7th graders. So the skill that we are working on is solving and graphing inequalities, and we have two quick examples that we're going to do, and then the back of the worksheet is independent. So the first example, I have negative 4x is less than 15. I want to get x by itself and figure out what that is. So in order to get one positive x, I need to divide each side by a negative 4, because a negative 4 divided by a negative 4 will equal a positive 1x. And if I divide the left side by negative 4, I have to divide the right side by negative 4. And this is where I'm going to pause, because I see that I'm dividing both sides by a negative, so I have to flip my inequality sign. So the less than sign is going to become a greater than sign. And I have 15 divided by negative 4. Well, a positive divided by a negative, I know will be a negative, so I'll put that in. Now, 4 times nothing gives me 15, so I have to do long division, top and bottom out. 15 divided by 4. 4 goes into 15 3 times. 3 times 4 is 12. I subtract and I get 3. There's two different ways. We could do this as a decimal or as a fraction. I'm going to do it as a decimal. So I'm going to put a decimal here and a 0. I will bring that down. 4 goes into 30, I know. Make sure we bring our decimal up. 4 goes into 30 7 times. 7 times 4 is 28. I subtract and get 2. Now I still don't know what it's going to be, so I need to add another 0 and bring it down. 4 goes into 20 now perfectly 5 times. 5 times 4 is 20. I have nothing left. So 15 divided by negative 4 is going to be negative 3 75/100. Now, if I'm graphing this, it doesn't have to be exact, but it's going to be pretty close. I know that negative 3 75/100 is closer to negative 4 than it is to negative 3. I'm just going to do my number line 1, 2, 3, 4 on this side. Negative 1, negative 2, negative 3, negative 4. Negative 3 75/100 is closer to negative 4. Oh, and this is my bad. I will put a point about there. This is a greater than, which means it's going to be an open circle. I'm going to shade in everything to the right. All right, the next problem is on your own. It's similar to this one, so if you need to come back and get a refresher or how we did it, head back, watch this part of the video again, and then there's one more example that we'll do. All right, if you hit play right now, you're ready for the second example. Our second example is g times the quantity 2 plus 5 is greater than or equal to 21. Now, there's two different ways you can do it. So on your paper, I would draw a line down the center, and I want to show you two different possible ways. And hang on a second, let me see if I can get a marker that's right and a little bit better than this one. All right, so I draw a line. There's two different ways to do it. I'm going to solve it the first way. We know we can distribute. I have g by itself, which means I have 1g. 1g times 2 is going to be 2g's. 1g times 5 is going to be 5g's, and this is going to be greater than or equal to 21. I can just combine terms. 2g plus 5g is going to make 7g is greater than or equal to 21. I will divide both sides by 7. G is greater than or equal to 3. That's one way to do it. With distribution, because when I see parentheses, that's the first thing I think of. You can also do something else. Because the parentheses just have regular numbers, I can add these two together. There are no variables. So I can combine these like terms. You can do that 2 plus 5 equals 7. So I know I have g parentheses 7 is greater than or equal to 21. Now g parentheses 7 just means g times 7. I can rewrite this a way that I prefer to look at it, which is just 7g is greater than or equal to 21. Divide both sides by 7. You get g is greater than or equal to 3, just like we did the last time. This way is a little bit faster, but if it doesn't make as much sense to you, do it this way. Both ways get you to the same answer. We have g is greater than or equal to 3, so the last thing we need to do is graph it. I'm just draw my own points. 1, 2, 3, 4. -1, -2, -3, -4. I know that it's at 3 and it's a greater than or equal to, so it's a closed dot. And because it's greater than, it's everything to the right. The next example you have is very similar to this one. So if you're confused at any point, you can come back and rewatch this one. Or if you want to try the next one both ways, again, you can come and rewatch it. You then have the back side of your packet, which is independent, and then you can do ST Math.